Where we else use this hashing is in the public key infrastructure, because we can use it, as mentioned before, for file validation, and also when we have public key and private keys to ensure that the content that we are receiving are actually from the person that we are expecting it from. So, for example, we have right here the signing part, so this will be the sender. He has some data he wants to send from A to B. So in order for B to check and ensure that it is A sending it, what our A part is doing in the signing process is that he take his data, run it through a hashing function, then he will get a hashed value, then he will take this and encrypt the hashed value with his private key, then he will have the certificate plus the attached signed hash value, which is now encrypted, and the data is encrypted as well. But the nice part about this, if you remember public private key, is that when we encrypt the data, we can use B's public key. So again, if you haven't watched the previous lecture, then please do so to fully understand the public private key infrastructure. But when encrypting the data, we will use B's public key, because when using his public key, then we know that only his private key can unencrypt this. But since it is his public key that we use for encrypting the data, everyone else who has this public key can also use this, and then he can't really tell if it was us or someone else who used his public key to encrypt it. But we can then use our own private key to encrypt this hashed value of the data, because our private key has a corresponding public key, and B can then use our public key to unencrypt our hash value, so he can check the hash value is coming from us, and when he uses his own private key to encrypt the data that we encrypted using his public key, he can then run it through a hashing algorithm, and he can see whether these two values matches. So this is what we see on this picture. So first we take a hash of the data, then we use the public key of B to encrypt it, then we use our own private key to encrypt our hashed signature value, we add that to the entire data package. What B is doing to verify that it is us who has sent the package is he divided, meaning that he will split the data and the hash value, then he will use our public key to decrypt our hash value, then he will use his own private key to decrypt the data, then he will take the hash of the data he received and compare it with the hash that we sent him, and if these two match, then he knows that this file were actually from us and not from somebody else. So now let's see where you can generate hashes on your own on the web. So there are actually multiple places you can do this. This is just a simple one where you have different algorithms to play with. So as we see right here, we can choose an algorithm. So let's take share one, and then we can write a message. Remember to like and subscribe to our channel. Then we can hash this. And as you see here, we have a hash value using the SHA-1 algorithm. And if I change a single bit in this, for example, just to A, and we do the hash again, this will be completely different. And as you see, it is a total different hash value we have. And this is really how you can try to play along with this and test it on your own.